So today we're going to cover section 2. Today we're going to talk about congruent polygons. So when you have two congruent figures, they're going to be figures that have the same size and shape. All the corresponding parts of one figure are going to be congruent to the corresponding parts of the other figure. So we're going to need, when it's a triangle, to match each angle. So we'll end up with 3 congruency statements for all 3 angles. And then we're going to find 3 congruency statements for the 3 side lengths. So what we're going to look at in this picture are the congruency marks. Now, when we write our final congruency statement, the order is going to be important. So what I'm going to go ahead and do is I'm going to start matching the angles first, and I'm going to look at the markings. So I need to come up with 6 congruency statements, and then after I write out the 6 congruency statements, 3 for each angle, 3 for each side, then I'm going to write a final triangle congruency statement. So in my picture, I can see that angle A is going to be congruent to angle F because they both have that single congruency mark. So this is congruent to this. Then I can also see that angle B is congruent to angle E. They both have the double line there marking that they're congruent. And then the next angle pair that is congruent will be angle C and angle D. They have the 3 lines. Now I have to go through and match up the 3 side lengths. So notice I have AB here with a single mark, and it's going to match with FE. So I'm going to say that AB is congruent to FE. Notice how I went from the single mark to the double for the order here. Now I can go to the next side, and it doesn't matter the order you write these. So I'm going to say AC, it's got the double, so it goes from A, which had a single mark, to the C. So I'm going to do AC is congruent to FD. And then lastly, the one with the 3 markings, BC, congruent to ED. Now what I need to do is write a final congruency statement for the triangle. Notice how I put, when I was comparing the angles, I put the angle symbol in front of the letter. When I was comparing the side lengths, they were segments. Now, you could technically leave off the segment picture of it on top of the letters, because the segment, remember, when you put the 2 capital letters, that's the only one that technically doesn't need a line on top. So now, to write the congruency statement, I could go in order of what I've written here for my angles, and then I'm going to write it as triangle ABC is congruent, and write down the same order on this side, to triangle FED. Now, if you notice in your congruency statement, the first letter, A, is matching with the first letter in the other triangle. So this tells me A and F are congruent. And then you can do the B and the E, which is what you wrote here. And then lastly, the C is the last letter in the statement, and it matches with the last letter in the second triangle, and C is congruent to D. So if they don't give you a picture with congruency marks, but they give you the congruency statement, you can use that to figure out the corresponding congruent parts. Right now, we do not know any shortcuts to prove triangles congruent. So whenever they ask you to prove that two figures are congruent, you must show every single corresponding angle and every single corresponding side has a congruent match. Later on in the chapter, we're going to learn some shortcuts. So we'll only have to look for 3 pieces that are congruent in order to prove triangles congruent. This theorem is called the third angles theorem, and all it states is that if 2 angles of one triangle are congruent to 2 triangles of another triangle, then the third angles are also congruent. Now, when you're writing this as a reason and a proof, if you want to abbreviate it, and let's say you want to say it's third, you could put, instead of writing the word third, you could put 3 with RD, and then put the little angles symbol, and then abbreviate theorem as THM. Or you could just write out all the words. But we will be using this theorem as a reason in our proofs. So what it states down here, based on the picture that's provided, is that if angle A is congruent to angle D, and if angle B is congruent to angle E, then you can conclude that that very last angle, C and F, are also congruent. So as soon as you show that you have 2 pairs of congruent angles, by default, that third one is also going to be congruent. So for example, let's say I told you that angle B is 80 degrees and angle A is 20. I can use my triangle sum. I can add 80 plus 20. Subtract that from 180 to get my missing angle, which is 80. And then I can do exactly the same thing in the other one. Well, if this has the same congruency mark, this one's 80, this one's 20, and then this one would also be 80. Now I know it doesn't look like it's an isosceles triangle, but whenever you have 2 congruent angles, the sides across from them are also going to be congruent. So remember, you can never assume from what the picture looks like what type of triangle it is. You always are going to need to do the calculations. 1, properties of congruent triangles. These are the same properties that we have already been exposed to when we talked about the algebra proofs, the reflexive, symmetric, and transitive property. We also applied them to angles. We also applied them to segments. And now we're applying them to triangles. So same properties. Reflexive is just like a mirrored image. It's like a reflection. Triangle ABC is congruent to triangle ABC. Remember the symmetric property, the order switches, or again, think of it like a line of symmetry. This matches, and then this matches. And then for your transitive property, remember this DEF would cancel out, and then you can conclude that triangle ABC is also congruent to triangle JKL. So the same properties we've been seeing all along, but now we're applying them to triangles. The next slide has sometimes, always, or nevers. So the first one, they want us to complete it with sometimes, always, or never. What I'm going to fill in here is when it's always, I'm going to put a capital A. When it's sometimes, I'm going to put a capital S. And when it's never, I'll put a capital N. So an acute triangle is sometimes, always, or never congruent to an obtuse. Never. Good. Okay? Because remember, an acute triangle needs all acute angles, And an obtuse triangle needs one obtuse angle, so they'll never be congruent. A polygon is sometimes, always, or never congruent to itself. It's always good, because it's the exact same polygon. A right triangle is sometimes, always, or never congruent to another right triangle. Sometimes, good. Okay, so if it has exactly the same other two acute angles, then that's when it would be congruent. But when it wouldn't be is when you have two different ones. So for example, let's say we have the right angle, and let's say these are 45 and 45, and this could be triangle ABC, and then XYZ. If it's got 45 and 45, then it's congruent. But let's say XYZ didn't have 45s here. Let's say instead, this one had 50 and this one had 40. They would both still be right triangles, but in this case, they wouldn't be congruent. So that's why it's sometimes. The number 4, if triangle ABC is congruent to XYZ, then A is sometimes, always, or never congruent to Y. This is going to be sometimes, because if you use the congruency statement, remember A is, in order for these to be congruent, A is supposed to match with X. However, if you have an isosceles triangle, then A will also match with Y. So sometimes it will, sometimes it won't. The time that it will be congruent is when the triangles are isosceles. And then the last one, if triangle ABC is congruent to XYZ, then A is sometimes, always, or never congruent to X. This one is always, because it is the first letter and it's going to match with the first letter there. So in order for those triangles to be congruent, A and X have to be the same. Now, this congruency statement is going to be really important to you, because sometimes when you're asked to determine if two triangles or two quadrilaterals are congruent, sometimes they're going to be pictured not sitting the same way. One might be upside down. So this is how you can use your congruency statement to figure out what matches. So on the next slide, we actually have two trapezoids. They're two quadrilaterals, and this time they're sitting the same way. So it's easy to see what matches. However, if they weren't, then we would use this congruency statement. And the congruency statement tells me that angle A is going to match with angle F. And then angle B will match with G. And then C matches with H, and then lastly, D is going to match with K. So notice what they want me to find is the value of X, and X is over here. I can go ahead and actually, I'm going to use GF. Notice G and F are the first two letters here. So it's going to match with the first two letters in the statement here. So GF is going to be congruent to AB. So the equation I'm going to set up to solve to find X is going to be 3X minus 6 is equal to 9. I'm going to add 6. 3X equals 15. Divide by 3. And X equals 5. Now, if you look at trying to find the value of Y, notice it's in an expression with an X and a Y. So this is why it was important that I found the value of X first, because I'm going to use that to find Y. And I'm going to look and see, I have K, which is where my expression is. So it's right here. And notice K is the last letter in my statement. So I'm going to match it with the last letter in the statement, which is D. So my equation that I'm going to set up to solve is going to be 4x plus 2y equals 44. Now you might say, well, you have two variables. How can you do that? I just found the value of x. I'm going to plug that in to my equation here. So now I'm going to do 4 times 5 plus 2y equals 44. I'm going to multiply. I'm going to subtract. 2y equals 24. Divide by 2. And y equals 12. So my two answers are 12 and 5. So this statement will be very important just in case your pictures are not sitting the same way. And what I mean by that, let's say if I gave you a triangle sitting like this, let me go ahead, do it in a darker color here. A triangle sitting this way, but then the other one is sitting this way. So by looking at the statement, it'll be easier to see which angles are matching. Let's look at example 3. So for example 3, it's a word problem. And they're saying Maggie took a piece of fabric and this rectangle is STUV, shown in the diagram, and cut it on the diagonal to make a scarf for her and a friend. Are the two pieces the same size and shape? So in order to figure out if they're the same size and shape, we need to make sure that all the angles match and all of the side lengths match. Now, because it's a rectangle, notice the congruency marks on the sides indicating that this side over here is congruent to this, and this side is congruent to this. Now, the two scarves that I'm talking about are this one down here, and then this one up here. So what I need to do is show that all three sides match and all three angles match. So I could go through and do the sides first because those are already marked for me, so it's nice and easy. So I'm going to check the sides first, show that they're all congruent. So notice SV, this one right here, is congruent to the side across from it, TU. And then I have ST at the top, congruent to VU at the bottom. Now notice the diagonal. Here's where I'm going to be using my reflexive property. I'm going to be saying SU is congruent to SU. And if you were writing this in a proof, your reason would be reflexive. So just a little side note there. Okay, now I have to show that all three angles. So now I've just shown that all three sides have a congruent match. Now I have to show all three angles of each triangle match. So we can see that V and T both have right angle marks, and we know that all right angles are congruent. So angle T is congruent to angle V because they're right angles. The other two angles that are in this picture are going to be alternate interior. And the reason why I can say that is because of my two lines being perpendicular to the same line, then I know my lines are parallel. So I know that these lines right here, I'm gonna do them in purple, because these lines are both perpendicular to this line, I know that these lines here are parallel. So now what I can use is the diagonal as my transversal. So here is my transversal, making angle 2 congruent to angle 3 because they're alternate interior. And then the same thing if I make my parallel lines SV and TU. I have parallels this way using the transversal, then angle 1 is congruent to angle 4. So the other two angles are going to be alternate interior, and they gave us numbers here to make it a little bit easier. So I could say angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. And the reason is that they're alternate interior angles. So now that I've established that all three angles in both scarves are congruent and all three sides are congruent, I will say yes, they are the same size and same shape. So yes, they are. Same size and shape. So right now, until we know the shortcuts, we must show that every single piece, every side, every angle has a corresponding congruent match. And the last slide has a proof. So we'll go ahead, and this could be similar to what you'll see on the quiz. You will be writing your own triangle proof on Wednesday. So the next slide would be a nice example of it. So the next slide, let's go ahead and set up our statement and reason columns. So number 1, I'm going to state all of my given. Don't be lazy, don't leave anything out. Because if you don't state it in the statement column, you can't use it in the proof. So SV is congruent to RV. TV congruent to WV. ST congruent to RW. And angle T, this angle symbol should have been over here. Angle T congruent to angle W. This was all my given. Now I'm also going to go and I'm going to label my picture just so it's going to help me to see what else I need to get into my proof in order to prove. And what they're asking me to prove is this triangle STV here is congruent to triangle RWV. So remember, you need to find all of the three sides marked as congruent and all three angles. So you're already given the three sides. So let me go ahead and put markings on those. So SV, congruent to RV, and then TV, congruent to VW, and then lastly, ST, congruent to RW. So all three sides have markings. Now I got to get some angle markings in here. Now they also gave me that angle T is congruent to angle W. So I'll put that marking on here. So now I just need to come up with two angles that are congruent. The obvious one, whenever this looks like a bow tie, I know it looks like it's on its side, but the bow tie, we always have a pair of vertical angles here in the middle. So this angle will be congruent to this. Now when I write this in my proof, I can't say angle V congruent to angle V. I have to name it with 3 letters because there's 2 angle V's going on here. Actually, there's 4, even the exterior ones. So I need to name these vertical angles with 3 letters. You can either start at the T and go to V to S or SVT. It doesn't matter. I'm going to go TVS is congruent to WVR. V needs to be the middle. And the reason why I can state that they're congruent is my vertical angles congruence theorem. Now I just need to find one more angle pair that's congruent, and I just learned a theorem today. If you remember, it's called the third angles theorem. So once you've established that you have 2 congruent angles in your proof, automatically that last third one will also be congruent. So I can go ahead now and state that angle S, 1, 2, 3 marks, is congruent to angle R. This case, since there's no other angle S in the triangle or R, I can use just one letter. Angle S congruent to angle R, and this reason is that third angles theorem, and I'm abbreviating. Now that I've established that all three angles have congruency marks and all three sides, I can now state what I was asked to prove, that triangle STV is congruent to triangle RWV, and my reason is definition of congruent triangles, and I'm abbreviating. And that is the proof. And you might have something similar, this type of length on the quiz on Wednesday. And that is it for section 5.2.